guys.
Welcome back for another lesson. This one is the computer timeline. Okay, so do now. Think about what can you do with the computer besides just browsing the internet. What else can you do?
Did you know your mobile phone has more computing power than the entire US government and NASA had when they landed to Apollo 11 rocket on the moon? So the phone can do many things and is very powerful.
So today we will learn about the history of computing to be able to present data from a variety of evidence in order to understand events of the past, together with using foreign language to search for and collect various data by using computers. So the vocabulary, the first is high value, so something which is very valuable, not just in terms of money, but also in terms of resources.
Okay, the second one, powerful. So a computer is something powerful, a phone, or like someone, like a politician or someone important can be powerful. That's an adjective.
So laptop, today everybody knows what a laptop is, but the word comes from lap and top. So basically you can use the computer sitting on your lap. So it is very different from the desktop, which sits on your desk.
The second last, a develop, the verb. So a computer can develop something, or a phone to develop something new.
And last is device. So device is usually an object, mostly electronic, that is capable of performing certain tasks.
So here we have a timeline from the computer. From the first one until now. You can see a big difference. Here just without screen. Then see all the evolution.
And next we have a design from Apple Computers. It was formed in 1975. And then they came up with a whole range of computers. So they were the first personal computers selling directly to users.
You can see the prices from the first Apple, $667, and now $1,199. We have even before $5,500, the Macintosh. So you can see Apple very expensive.
Here we have a few inventions for you before the computer. So in 1876, Alexander Graham Bell invented the telephone. And on the right-hand side, you see a calculator. So Blaise Pascal invented the calculator in 1642. So this would you would input the numbers, and it would give you an output. Sometimes on a paper, or sometimes it would show the answer on you can see the white colored scrolls there.
And the first computer was invented by Charles Babbage. This one is a computer. You can see compared to now, it's a lot of difference. That was in 1936.
And the mouse was invented in 1963 by Douglas Engelbart. And then after he invented it, he went to work for Xerox. If you know the company, the Xerox machine. So Xerox was the first company to use the mouse in the personal computer.
The video games invented in 1962 by Steve Russell, Space War. It was on the computer and also the phones, very famous. So you can see the graphic design was very different, huh?
And then finally, we have Toshiba that invented the first laptop in 1985. Okay, So Apple came up with some very good designs in 1970s with the desktop, and then Toshiba came up with the laptop.
So early in their history, computers were a high-value, expensive machine. They were used by only government, scientists, or military. So when technology became cheaper, we began to see consumer computers. And these are cheap but powerful computers which are available to everybody. Before was only government and army. And now everybody has a phone and can do whatever we want with it.
So here we have basically a timeline. This is to give you an idea. So what we would like you to do is we'll show you some slides and try to write them down in a timeline fashion using this template.
The first two dates. 1613, the word computer was first used to describe a person who performed calculation.
And then in 1822, Charles Babbage developed what was called the difference engine. And he had help from another scientist named Ada Lovelace. And they could basically do calculations and give you the results in a printout.
In 1837, Babbage proposed the first mechanical computer, the analytical engine, but he wasn't able to build it while he was alive.
And in 1936, Conrad began work on the first electromechanical computers. So today we all have a hard drive. So the hard drive reads all the data from the operating system and shows on the laptop. But before that, they didn't know how to read data. So they were reading data from this 35 millimeter film, which we also use to take photographs.
In 1936, Alan Turing began to develop the Turing machine, which was the foundation for ideas about computing.
And then in 1943, this was around the time of World War II, Tommy Flowers built a machine which was known as Enigma. And it was the first electrical computer which could read encrypted German messages. Sorry, the name of the computer was actually Colossus, and Enigma was the name of the code, which was the German code, and this computer was able to break that.
In 1949, the EDSAC performed its first calculation. This computer ran the first graphical computer game.
And in 1950, we had the UNIVAC. That was another machine that you can look. It looks like a control room, and that could store and run a program from memory.
In 1960, the first computer mouse was invented.
And Hewlett-Packard, which is a company we all call HP, started selling the first desktop in 1968. Another interesting thing is Hewlett and Packard were two engineers, and they founded Silicon Valley in the US.
1973, the first mobile phone call was made.
And you can see that I think that the phone was made by a company called Motorola in the US. And in 1975, you had the first portable computer that was sold. And this was the IBM 5100. It had a 5-inch screen and was almost 55 pounds. Okay, so before it was only sold to the military and the scientists, but this was the first time that it was sold in the open market.
In 1976, Apple, the computer company, sold their first computer, the Apple I.
And in 1985, the first version of Microsoft Windows was released.
In 1986, the first PC virus was released into the wild.
And the internet, or the World Wide Web, was invented in 1989 by connecting computers in the US.
1996, Google began as a research project by Larry Page and Sergey Brin.
And in 1999, we had a problem called the Y2K problem. When they first designed the computer, they did not think what would happen beyond the date 2000. So if the date hit 2000, then all the dates in the computer would go back to 000. So this was a big problem called the Y2K bug, and a lot of people were working to solve this problem, and they finally managed to solve it.
2005, YouTube was launched, allowing users to upload, share, and view videos online.
A little bit of research for you. Try to find out for how much money did Google buy YouTube in 2006. Okay, Google bought YouTube in 2006. How much did they pay for it? And in 2007, you had the first iPhone that was launched.
2012, the 1 billion users registered on Facebook.
And 2014, Minecraft, which is a very famous game, was bought by Microsoft for $2.5 billion.
That was it for the timeline. Now we're going to watch some videos. The first one with Elon Musk, the neurological brain, and then the quantum computer. Quantum you should know from Marvel, so it's high technology. So open your notebook and watch both videos.
Quantum physics, one of the most successful theories of modern science, describes the way our world works at the most fundamental level. Quantum computing has become one of the leading applications of quantum physics. Quantum computers have the potential to solve some of the world's most complex problems that are beyond the reach of even today's most powerful supercomputers. Quantum computers are not going to replace classical computers, but their radically different way of operating enables them to perform calculations that classical computing cannot. Let's see how they differ. Classical computers encode information in bits, and each bit can represent a 0 or a 1. These zeros and ones act as on-off switches that ultimately translate into compute functions. To perform a simple calculation, like solving a maze, a classical computer would test each possible route one at a time to find the correct one. Just as classical computers have bits, quantum computers have qubits. Qubits, however, make use of two key principles of quantum physics: superposition and entanglement. Superposition means that each qubit can represent a 0, a 1, or both at the same time. And entanglement happens when two qubits in a superposition are correlated with one another, meaning the state of one, whether it's a 0, a 1, or both, depends on the state of another. Using these two principles, qubits can act as a much more sophisticated version of switches, helping quantum computers solve difficult problems that are virtually impossible using classical computers. To illustrate how this makes quantum computers more powerful, let's look at some numbers. Take a classical n-bit computer, with n representing the number of bits. It can represent and examine only one system state at a time. An n-qubit computer, however, would have the power to represent 2 to the power of n system states and perform parallel operations on all those states at once. This means that every time you add just one more qubit to a quantum computer, the number of states it can represent and examine doubles. So a 50-qubit quantum machine could examine 2 to the power of 50 states at once. This exponential increase in power, together with the entanglement of qubits, is what allows quantum computers to solve certain problems so much more efficiently. While a classical computer solves a problem like the maze by testing each possible route one at a time, a quantum computer uses its entangled quantum states to find the correct route quicker, with far fewer calculations. Think of it this way. Technologies that currently run on classical computers can expertly find patterns and insights buried in vast amounts of existing data. But quantum computers will deliver solutions where patterns cannot be seen because sufficient data does not exist or the possibilities for discovering an optimal answer are too enormous to ever be processed by a classical computer. Quantum computers could lead to the discovery of new medicines and materials by helping us untangle the complexities of molecular and chemical interactions. They could help the financial services industry make better investments by finding new ways to model financial data and isolate key global risk factors. They could even transform supply chain and logistics by finding the optimal routes across global systems, like optimizing fleet operations for deliveries during the holiday season. Quantum computing won't replace our everyday computers and smartphones, but its ability to solve complex problems will open up a new universe of information, transforming our view of the world and the way we navigate it.
You're on vacation in a small village in France, but don't speak a word of French. Imagine if you could download a program into your brain and converse with locals. And what if you could later remember that trip in perfect detail?
In the future, you will be able to save and replay memories. This is obviously sounding increasingly like a Black Mirror episode.
Elon Musk says you will even be able to store your memories as a backup and then download them into a robot body. It sounds like science fiction, but Neuralink believes it could make that happen one day with this chip. It's a brain-machine interface, or BMI, a device that connects your brain to a computer. But before chasing these superhuman goals, Neuralink is focused on one thing: ending human suffering. All of our senses, sight, hearing, touch, smell, taste, are electrical signals sent by neurons to our brain. But sometimes the signals are not wired correctly. Neuralink wants to rewire the circuit so that the paralyzed walk, the blind see, the deaf hear, as well as treat other neurological disorders such as depression, insomnia, Alzheimer's. The battery lasts a full day and can be charged inductively as you sleep, possibly by wearing a nightcap, according to Musk, although it may not look exactly like this one. The prototype is different than 2019's. That one required an external earpiece, whereas the latest version involves just the chip sitting in the skull.
It's kind of like a Fitbit in your skull with tiny wires.
The wires, or threads, are 10 times thinner than human hair and represent electrodes. The electrodes figure out what's happening in the brain by reading the signals sent by the neurons and then stimulating as many neurons as possible. This technology is not new, but what makes Neuralink drastically different from other neural interfaces is that it will insert significantly more electrodes to stimulate neurons on a scale never seen before. As a comparison, Utah Array is considered one of the best BMIs out there right now and has been used to study conditions like epilepsy. It has around 100 electrode channels, whereas the current version of Neuralink has more than 1,000 and possibly much more in the future. Also, the threads are thinner and more flexible, greatly reducing the risk of piercing blood vessels and potentially causing catastrophic damage. But that doesn't mean humans are capable of the precision required for surgery. At the eventual cost of a few $1,000s to the patient, this robot could one day do the entire operation in under an hour, leaving the chip relatively concealed.
All you can see afterwards is this tiny scar, and if it's under your hair, you can't see it at all. In fact, I could have a Neuralink right now, and you wouldn't know. Maybe I do.
That's unlikely since human trials haven't begun, but they have done tests on animals.
So what we have in pen number 1 is Joyce.
Joyce demonstrates what a normal pig is like without Neuralink.
So here's Dorothy.
Dorothy used to have the device, but no longer, and she appears to act just like Joyce.
Gertrude, are you serious?
Then there's Gertrude, the one who's had an implant for 2 months. It took her a while to get with the program.
Oh, the beauty of live demos. Gertrude, thanks for coming out.
The beeps are signals from the area of her brain linked to her snout, so when she ate or sniffed the straw, the activity showed up on the graph. The implant has also helped the team predict the limb movements of a pig on a treadmill with what they describe as a high degree of accuracy, but it still remains to be seen how people respond to it. Neuralink has to get a stamp of approval from the U.S. Food and Drug Administration to start human trials geared toward helping those with spinal cord injuries control a computer.
We will make this as safe as possible. Just as with Tesla, while it is legally possible to ship a one-star car, the only cars we make are 5 stars. We actually maximize safety, and we'll take the same approach here at Neuralink.
But there are some signs of chaos at the young company. Former employees told Stat, an American health-oriented news website, that rushed timelines were often clashing with science's slow pace. Musk said last year he hoped the trials could begin by the end of 2020, which seems highly unlikely. And then there are the privacy issues that scientists have been urging governments to address, including what data should be collected and how it will be kept safe. So it will likely be a long time before this becomes a reality. But Neuralink has plans to expand rapidly. At its headquarters in Fremont, California, it has a massive space but only 100 employees. In a few years, it expects to grow to 10,000, which would be more than the number of staff currently at SpaceX. Although the scientists and engineers will continue to work toward curing brain disorders, that's not the main reason Musk created Neuralink. He has repeatedly spoken of the fear that humans will be overtaken by artificial intelligence, based on the hypothesis that if AI becomes super intelligent, it could be difficult or impossible for humans to control and potentially result in our extinction. So his solution is to sync up the human brain with AI and create a symbiotic relationship. Symbiosis refers to the art of living together. We see this in nature, in the mutually beneficial relationship between sea anemone and clownfish, for example. The anemone provides shelter for the fish, while the fish provides it nutrients and protects it from other predators. In the same way, humans and AI can grow together. Although Musk has many ambitious projects on the go, this one seems different than the others. SpaceX wants to build a city on Mars, changing where we live. The Boring Company is building underground tunnels, changing how we travel. But Neuralink is changing us, making us in many ways superhuman.
The future is going to be weird.
And that may be an understatement.
Thanks so much for watching. I'm Cindy Palm. So would you ever get the Neuralink implant? If not, why not? And if so, what capability would you want to see the most? Let me know your thoughts. You can leave them in the comments section below. If you like what you saw, give it a like. And as always, don't forget to subscribe to my new channel. A big shout out goes out to my patrons as well. I'll see you soon.
So welcome back from the videos. So if you haven't done it, go back to the video again and watch the timeline and write down the date and what happened during that time. Okay. So here we have we've tried to do something new. So on the right hand side you have the mind map, and on the left hand side you have the diagram. So you have to do this on an A4 size paper. So for the mind map, you have to write down people who develop computing devices. Okay, so anything that is related to computers or calculations, you have to write down, and the date, and also you write down what people use computers for in the past. Okay? So could normal people buy the computer, or was it only the government and the military? So think about that. And on the left hand side, from the video, write down the dates and the timeline of everything related to technology that we have showed you.
Evolution of computers. Write whatever you learned from this lesson. And then don't forget to write the vocabulary in English and try to find the meaning in Thai.
And finally, do the mind map and the diagram of the history of the computer on an A4 size paper. Okay.
Okay, see you for the next lesson. Bye bye.